A new model, Microsoft Lens, has been released, and the model is great for systems with smaller graphics memory. The images were trained with decent captions generated by GPT, so this model should understand the prompt better. These are the sample images, and the images this model generates are not restricted to 1024 pixels. The model is available on Hugging Face, and these are the original links to the model weights. Below is the directory to place these models given for comfyUI. These are the 3 files required to generate text-to-image. Inside the diffusion model folder, there are 2 types of models. The first is the base model, which requires 50 steps to generate a final image with a CFG value of 5. And the second is the turbo model, which should give us an image within 8 steps with a CFG value of 1.0. This is the simple workflow to use the model. However, it was not working. I checked on GitHub, and the code review was pending. I tried getting this locally on my computer to make this video, but then it gave me a different error. After solving one error, I got 2 more errors, and then I ended up changing a lot of things in my comfyUI. While doing so, comfyUI released the update, and now it supports the new model. After messing up, I had to download the comfyUI portable again, and then updating the project using this update batch file. Later, I installed the comfyUI manager. The workflow worked, and this is the image generated. The image looks bad because I am using the turbo model with a CFG value of 5 instead of 1. Changing it to 1 gave me a decent image. So the whole point of using this model is that it's trained on much better captions, which means it understands prompt a lot better. The model is also really fast. And the best part is it can generate high-quality images even on smaller GPUs. I saw many users were not able to make this work even after updating comfyUI. The problem they mentioned was that this lens option was not found in the dropdown. Changing this value to Flux 2 should also work, but after updating, you should get this lens option. The turbo model is working with this workflow, so I will get the other model now. Both the models we saw earlier have a new variant now. The MXFP8 is smaller in size, and it is optimized for Blackwell cards, which means if you have the latest 5000 series cards, then this file should work great for you. The MX SafeTensor file is available for both the turbo and the base model. Also, there is a GGUF model present, but the original model is already small in size. You should try the original model even if you have a 6GB GPU. So I will get the BF16 model and save it in the diffusion model folder. And the workflow for the BF16 model is below. Press the letter R to refresh the model list and select the model. The number of steps will be 50, and I ran the workflow. The turbo model in the above workflow took 11 seconds to generate an image, and the base model took 60 seconds, but I forgot to increase the CFG, due to which the image generated is not the best we can get from this model. I will be using some negative prompts here as well, and then try again. Now the image generated is something I was expecting, with a size of 1440 pixels. I will try a few more images. My prompts will be the same for both models, and I will be using this string node for that. My prompt was food photography shot of steaming ramen bowl with rich umami broth appeal and slurpy noodle comfort. The image from the turbo model is on the left, and the image from the base model is on the right. The way chopsticks are being held looks wrong to me. The rest looks fine. Total time taken was 135 seconds, where the turbo model gave the image within 10 seconds, and the base model took around 2 minutes to generate an image. The prompt I used here was a very detailed prompt, and all the prompts will be shared with the workflow. A joyful robot chef in a futuristic kitchen, flipping pancakes midair with a big grin on its face. Stainless steel surfaces, steam, and hovering utensils. The prompt here was based on the assumption that the training data may not have images where a robot is cooking pancakes. This image is definitely a challenge for a 3 billion parameter model. A human astronaut riding a penguin on the surface of the moon. The image generated by the base model looks acceptable, but there is something wrong with the penguin on the left, maybe due to a lack of atmosphere. 4 flags with a single letter LOVE on them. Each letter of love is on a separate flag. Multiple spotlights in green, blue, red, and yellow. The base model did the job exactly as mentioned in the prompt. My prompt was a giant holding a person in his hand, and both the person are looking at each other. Image generation models often get confused about the size of the subject with the objects around it. I asked for a person, and the image generated was of a young kid. The image definitely shows that the model somehow managed. In this image, I wanted to check the reflections. It was fine, but the woman looks different in the image generated by the base model. I thought of using the same image and adding details to it. So I made an image-to-image workflow, and my prompt is a highly detailed image. The result generated is of a different woman because the denoise value here is 1.0. The value should be somewhere around 25 or 30%. So it works. A detailed prompt should make this image perfect. I was using the turbo model. You can also use the base model instead, which should produce a better result. The image-to-image workflow and text-to-image workflow for both types of models we saw will be shared in the description. You should check this out if you are running a 6 or 8 gigabyte GPU. I did something similar in one of my older workflows. In the previous video, which was about the HiDream model, where I was using a LoRa, which made the final result better. I have updated the same workflow by adding a similar image-to-image workflow, where the image from HiDream will be processed again using a Z-Image-Turbo model. Now I can use the image editing capabilities of HiDream and can also get a detailed image from it. The denoising value is at 35%. Increasing this will allow the model to make more changes in the subject. So make sure to keep this below 40. This image got overcooked due to the number of steps. I am using the HiDream Dev model, which is a distilled model. 30 steps are enough for the final image. Keep it above 30 when using the base model. Also, make sure to look at the CFG, which should be at 1 when using the distilled model. This workflow did the job for me to make a few product images for my clients, and they were happy, so I shared the workflow. Hope it helps.